Yes, so to go over the experiments that we conducted after the midterm, we'll start with the regenerative turbine pump, which is experiment number 5. Basically, what do we have over here? We have the motor side and we have the pump side. In the pump side, casing side, we have the section, which is from here, and then we have the discharge, and this is the tap for priming, which is removing the air from the system to have a sufficient efficient system. If we open the casing itself for the cover, we can see the regenerative turbine pump wheel. This is, as I said, they are very similar to the centrifugal pump, but in centrifugal pumps we are using the impeller, which has the impeller eye, shrouds, and vanes. The amount of fluid that can be delivered using the impeller or centrifugal pump is higher than a regenerative turbine pump. Designed different in the wheel itself. You can see that this is the impeller. How does it look like? And this is the buckets of a regenerative turbine pump where the fluid is stuck. Fluid in regenerative turbine pump will have to take many turns before the goes for the discharge. Okay, so amount of pressure and efficiency of the regenerative turbine pump is higher, but in terms of fluid or the volume, it is different. Now removing the wheel, as you can see now, these are the wheel and these are the buckets where the fluid can be stuck and stored. We have the mechanical seal as well. Mechanical seal is responsible to stop any leakage. This is the stationary part of a mechanical seal, and this is the rotary part here in the inside with the spring pillows and so on, as we have taken it before. This is basically a regenerative turbine pump and the components. Now we'll jump to the other experiment. Experiment in the row that we have, it is the piston pump, a double acting piston pump. The components of it, we have bearings over here, we have another bearing over here, and another bearing on the other side. In here we have the crankshaft, and this is the connecting rod. This is the piston head, sometimes called a cross head. This is the piston rod. Okay, and in the bottom side of here, this black part is the compression. If you can see it, it is the compression disc or compression. Can you see it? Now this is the black part over here. This one over here, it is the compression disc or compression head. This is the cover for the compression chamber. This is the cover of compression chamber. If we open it, we can see a gasket, and then we can see the valves. Fluid enters from here, so these are the suction valves. You can see. Take it from the other side. These two are suction valves. Remember that valves are installed this way, not the opposite way, otherwise the piston head might be broken. Fluid will enter through the cavity or the holes over here to inside the compression where the pistons, the compression head will be. What happens now in the double acting, as we explained before, is that if during one stroke or completing one stroke will do two actions. For example, if the compression head is going to left side, that means what is happening is that they are compression in this side. That means the discharge valve will open in this side, and suction valve will open to in the other side. So if the compression disc goes back, right, or head goes back, what happens? It will have a compression over here, so discharge valve will open, and suction valve in the other side will be opened as well. Okay, so this is the section. So these are the component as we have explained, and in here we have additional parts just like the gland follower to overcome any leakage also as well, to protect it, and a mechanical seal inside to avoid any leakage. It will be run by a driver, which could be turbine, motor, or a generator by means of belt and pulley. Now we have the external gear pump. We says that we have two types of gear pump, internal and external. External gear pump, both rotors will be rotating against each other, and in the internal gear pump, both gears, if we are talking about two gears, will be rotating in the same direction. The components, as we have suction hole over here and discharge hole in the other side, which is considered to be smaller. And then we have end cover, casing, and flanged cover, which will be connected to a flange. Okay. Then opening the flange cover, we can see in the flange cover we have the guide pins. This is one and this is the other one, and we have bushings, as we've explained also in the class. The function of bushings, they are considered to be a journal bearing to protect the shafts from weeding, and in case of the increase of clearance, we can change the bushing. These are the bushing. These are considered to be a journal bearings, a type of journal bearing. This is the main rotor or the driver, and this is the driven rotor. Fluid, we say if the fluid enters from this side, so the rotational of the gears will be this way, so fluid will enter from here, couple between the teeth, and move with the teeth and the casing, and it will leave to discharge. Okay, we consider also by saying that an important information here is the backlash. To measure the backlash, you need to consider the following points. For example, if I'm taking the backlash in this area, so I need to take the reading for the two adjacent teeth together, meaning to say I need to center it first. I need to make it at center, just like this. And the second point is that I need to make sure that the main teeth that I'm talking about, will be touching any of these teeth, either this one or this one, fully. Okay, for example, like this. And then by using a filler gauge, I can take the gap over here. The filler gauge that we are dealing with, as I have explained to you, this is the filler gauge that we are dealing with. It says clearly here it's from 0.05 and 1 millimeter. And we have around 20 plates. Plates are not written this way. The plates will be described as 5, 10, 20, and so on. So what you need to do, the reading that you are going to find need to be divided by 100 in order to get the reading in millimeter. And then you need to redivide them by 2 because that the teeth themselves, they're supposed not to entangle or touch each other. The gap in here must be somewhere separated between. So the teeth, the middle teeth, the center teeth that we are talking about, must be in the middle between the teeth. That's why we recommend in screw pump, our gear pump, to open the suction valve so the fluid can enter between the teeth and so on, so in terms of lubrication, and to avoid any damage to the gears. Okay, so again, these are the gears. This type of gear is a spur gear. We have some bushing inside, and then we have a place for guide pin, where the guide pin, as we described before, will be seated. So now we will be discussing the Triplex screw pump, which is a type of a rotary pump, similar to the external and internal gear pump. They are different from the centrifugal pump in number of areas. Number one, the way that they are delivering the fluid. So the prime movers, the drivers themselves, rotors themselves are different. Number two, the volume in centrifugal pump is higher than it is in gear pump or screw pump. Number three, the volume. The pressure will be higher in the rotary pumps than it is in the centrifugal pumps, if you are comparing the same size. Number 4, that the centrifugal pumps requires priming, which is the removing of air from the system, unlike the rotary pumps or positive displacement pumps in general, where you don't require any priming. طيب, the triplex screw pump consists of the following: back cover and front cover in the front, and then we have the inlet and discharge. So this is the inlet and discharge. Okay, we will have some points inside. Again, this pump, as mentioned here, pump not to be run dry. That means you cannot run this pump dry. You need to pour in some fluid, or you need to open the suction valve so the fluid enters and the screws, they don't get damaged. When we open the front cover, the first thing we'll see the stationary face of the mechanical seal. This is the main rotor. This is the main rotor or main screw, let's say, and this is the mechanical seal. We have pillows, we have spring over here, and we have the rotary face over this side, just like what we have seen over here. And then we have two idlers. I said it's a triplex, so we have two idler screws. These are the idler screws. Note it will be coupled with the main driver screw as well, to deliver the fluid or create the pressure required for delivery. Again, section, discharge, back cover, and front cover with these elements. Okay, now finally we reach to the triplex plunger pump. This type of pump, or this pump, creates the highest pressure among the other types of pump with a similar size. Just like the centrifugal pumps, when we said that it is the most common used type of pump used in industry. We will be discussing the triplex plunger pump, the parts and function. Basically, we will start with the components. First of all, the first part over here is the cylinder head. Then we have the cylinder block, and then we have the crankshaft casing. Cylinder head has one section and two discharge, and you can close any of these. If the equipment or the process is going to right, you can close the left, or if it's fluid going to other direction, you can close the other side, just like this, using a tap similar to this one. Or you can use both, and for sure the pressure will be dropped a little bit. And then we have the cylinder block and crankshaft, as I said, explained over here. So in cylinder head we have, as I said, this is the section, and these two as discharge. We have attached to it a valve, a simple valve. If the valve was seated this way, that means the fluid enters from the top, pressing the disc over here and the spring, and the fluid then enters. If the valve was placed the other way around, that means it is for discharge. Fluid comes from the bottom, pressurizing or compressing the disc over here, as you can see, the small disc, and then from the small disc it goes to the spring, and then from spring the fluid goes to outside. Suction discharge valves are similar. Okay, طيب. Now again, cylinder head, cylinder block. The components of cylinder block: first we have the discharge. These are the sections, the area where section seated. This is, as I said, the fluid, the valves will be seated this way, the whole areas. These are the discharge, where fluid goes from the bottom through a channel, small channel over here, to discharge valves to discharge the compressed fluid. We have the process fluid drain port. Normally, this type of pump can be used as some like an injection, or as a dosing pump. So that means they can handle some kind of a difficult or caustic fluid or acid. To protect you or save you from any damage or from harm, what we can do is that before we bring this one to a workshop, we need to remove and drain the chemicals which is inside first, right? And then after you drain it, you can use it or bring it inside the workshop. Okay. Third part that can be found on the cylinder block is the dust pad. These are the dust pad. We have 3 dust pads over here. The main function of dust pad is to clean the plungers from any dirt and from the dust. Okay. Moving to the crankshaft casing. We have a crankshaft over here. We have crankshaft over here that runs the three plungers, and then we have the oiler where we can fill the oil. So here is the place where we fill the oil. Then we have bearing covers. We have one bearing over here, one bearing over here. They are ball bearings. So these are bearing covers. You can remove it to see the bearing covers. In the other side, we have the drain port, oil drain port, in which we can drain the oil if it's been expired. And then we have the side glass. Side glass function is to check the level and the condition of oil. Normally it becomes to the middle or a little bit lower than the middle. And this is the end cover. And then we have also the plungers. Plungers will have the similar components. They will have a connecting rod, a cap, which is directly connected to the crankshaft for power delivery. Again, these are the components that we have gone through. I hope everything is clear right now. If you have any question, don't forget or don't hesitate to send it to me. All the best, guys. Assalamu alaikum.